Hi everyone, I'm Rajat Sharma from Plus 2 Non-Medical
I am Kumar Devan from Plus 2 Science.
and we have come from DAV Public School, Lawrence Road, Amritsar to design a prototype as we have been selected in top 100 in ATL Marathon. We have come here to design and see and troubleshoot what grain storage problems the farmers and the people here face.
As per our previous prototype video, we have installed a humidity sensor and a temperature sensor in it. So now here we are at the storage facility in one of the local granaries to see and improvise our prototype so that we can decide what else sensors we can add in our granary so that it becomes more future proof. As per our last video, we described the prototype of our smart granary system. In that we had installed a humidity and a temperature sensor which could track real-time temperature and humidity of the storage facility where the grains are stored. Now here we are at a local granary to see what else we can add to our prototype so that it becomes more future proof and can be used to save even more grain from getting destroyed.
We are dealing in rice. There are cellos so we can store paddy and rice both.
Both can be stored finished and the raw product.
Yeah, but to my experience, it is not a good solution for rice. Reason being, it develops cracks.
Basically deteriorates the crop.
Yeah, it deteriorates, and even in the outer layer of the cello, it's a metal. The metal is rust proof, but outer layer will be in touch with the metal. Outer layer that is vulnerable to temperature variations. Bottom part over which the whole weight will be there of the grains.
It will get crushed.
Yeah, it will develop cracks. So best way we do have cellos, but we don't use it.
So basically our model as of now consists of a single moisture and temperature sensor.
Yeah.
So we are planning it to divide it in silos, especially the FCI silos for the Government of India, so that they can monitor the, as you said, that it is a bare metal silos and it is dependent on the outside temperature.
Yeah.
So we are planning to devise a sensor and a complete system, prototype system, which can be installed in almost any type of silo. Plus we are adding a humidity and temperature sensor. It will continuously measure the relative humidity of the silo and the temperature, so which can be viewed in real time through a phone application.
Okay.
Plus we are thinking of like regulating temperature in silos. Like you said, there is a metal wall.
Yeah.
So we are thinking of applying a layer of insulation and a cooling system inside the pipes will run through with water as the water temperature is needs to be tested, or the cold water will be tested so that the grain stays at the ideal temperature in the storage. Plus for any natural calamities like fire and fire breakouts, we are also including a fire alarm system which can be installed in each of the silos individually. So if any fire is any flame is detected, it will automatically warn the user. So
And for
rodents, we are also adding rodent proofing.
So if there is any rat or any pet, so
And we are also including a small camera inside the silo, night vision camera. So if you want to remotely view the silo from outside, condition of grain inside, for example, if you want you have some rodent motion on the motion sensor, you can directly view it from the camera installed inside. You can check if whether they are rodents or not, or anything is gone wrong. So according to you, what else can be implemented, or is there anything else that needs to be checked with the rice?
Have to see whether, first of all, you have to check the viability of this project, whether it is cost effective.
That only.
That needs to be done. If it is cost effective, then it will be a great thing for food grain storage.
So for the sensors are not that costly.
Yeah.
We are getting a sensor for 350.
Okay.
Easily available.
Yeah, easily available.
The microprocessor systems that we are using, they are also, one microprocessor system can support 4 sensors at one go. So the entire silos, which according to you, you are saying that despite that new facility, there are shortcomings, no one has upgraded and upscaled it. So finally, we do have a solution. First of all, to make sure that the already present technology can be brought into use
Yeah.
And then with a real-time monitoring, you don't need to be physically present all the time. Everyone has smartphones and it will all be Wi-Fi operated. So
for all the sensors, I have roughly estimated to convert one silo for that smart silo. You need for all the sensors only. It would roughly be, all including sensors, 20 to 30,000 for one silo. And if we further implement temperature control system, that will include heat dissipator, water tube pipes which need to be installed around, and insulation padding. That accordingly, if the silo is large, it depends upon what the volume of silo, and it will accordingly depend upon the size of the silo, the need for cooling and heat radiators. So it may range from 30,000 of single small, roughly estimated by diameter in what is the smallest size of the silo?
Any size. Any size. Can be customized.
Okay. So for rough estimate for 5 meter diameter, 5 meter across, and 10, 15, 20 meters tall, it would be approximately 30 to 40,000 for the insulation, water management, water cooling system, and 30,000 for sensors. So for that we go for silo, it may cost 80,000 rupees for the entire process.
That is reasonable.
and then the next part is that even if we want this to become more cost effective, we can spend some time and bring down the costs by juggling the components.
Some bulk production, cost will definitely come down. This you are calculating on a single cellulose basis. If there's mass production, it will definitely come down.
Like for Government of India, they procure wheat and rice from almost all.
Look, in wheat, maize, these type of grains, cellulose are successful.
But for rice,
For rice, we are a bit hesitant about using. We have cellulose, we have Brock USA cellulose, but we avoid using them. We use them sometimes when there is shortage of space or that.
that's the secondary, it's not your primary go-to solution. And when you have spent so much money on the silos and they are lying defunct, what is the point?
Yeah, definitely.
So for wheat and maize, actually, wheat and maize don't need that rigorous temperature and humidity, moisture.
They do need,
but they're.
but even if it is crushed, because they are ultimately their grinding is done, right?
So the crushing factor is eliminated.
But rice, it has to be used as a wholesome grain, right?
Yeah, full
So
grain.
the price of the rice is depending on the fact that it is a whole grain.
Most of the research universities and people are focusing on how to get the grain better.
The yield factor is more on, but whatever has been procured, what about storing that?
What they are doing, their focus is on pre-harvest.
Not the post-harvest
Post-harvest
and during
technology.
harvest.
Yeah, they don't care.
As you can see, we are now in a part of storage part of the factory. As you can see, due to human negligence, all this grain has been left here to rot, to be eaten by the parasites and pests, rodent attacks and everything.
By rodents, and you can see how the grains have been destroyed.
And remove the human error involved in the storage process, so that the small amount of grain is not wasted.
I am Ranjit Rajesh Sharma from Plus 2 Science.
I'm Rishabh Agarwal from Plus 1 Science.
I am Parth Gupta from class 7A.
I am Bhuvan Devkar from Plus 2 Science.
And today we are showcasing a prototype model of smart training, as we have been selected in top 100 of ATL marathon as per selected in Tech category.
The ancient granaries at the Harappa and the Mohenjo-daro were also known as the great granaries. They boosted of the security improvements from a guard hut, and they also had crane and brakes for the perfect insulation. They were set up in two sets of 6 rooms aligned with each other on the both sides of the central passageway, and also there was enough space for the cross ventilation. The sunlight was also at room level, and in case of rainfall there were also drain systems to drain out the water.
So as per our current field visits, we have found out that this is the common method of storing grain, especially rice and maize. Here the grain is tightly packed into jute bags and stacked in the form of pyramid, and is later covered with polystyrene bags to repel any water during rainfall. But this method of storing occupies a large area and needs proper maintenance for day-to-day moisture level checks. Hence, silos were designed.
Now, due to shortage of ground area, vertical storage units or silos have been erected, but they need their design needs modification, because as you can see, they have conical bases which have large area, and now when the grain comes down due to force exerted, they get crushed and the quality of grain is bad. So, our prototype, we have designed this silo which has a short slope so that grain does not get enough force and the grains that come out are good. Now, as per the challenges identified, we have designed a prototype to reduce human error and have real-time monitoring. So, in our prototype, we have included temperature sensors, humidity sensors, fire detection, modern proofing, and a Raspberry camera module, and cross ventilation, and board IoT background module.
Here, of all these things, we have used Arduino Uno and made different sensors. Here is the motion sensor, which sounds an alarm if there is a motion, be it a rodent, a stray animal, or some human with a stealing intention moving in the granary. So here you can see the alarm.
In case of fire breaks out in the granary, we have a flame sensor. So here is the working. The alarm has been triggered.
There are specific grain storage conditions. First, temperature and humidity. Temperature needs to be maintained between 15 degrees Celsius to 20 degrees Celsius, and the relative humidity should be around 19 to 16% of the grain. If the humidity drops below 14%, the grains will get stiffened up and will develop cracks, which will lead to poor grain quality. If the humidity rises up 20%, more than 20% mark, then excessive humidity will lead to development of fungi, which will release aflatoxins in the grain, which is not fit for consumption of humans.
For measuring the amount of the grains in the silos, we have also fitted an ultrasonic sensor with an LCD display which constantly shows the measure left in the silos in centimeters as well as in the inches.
So when there is a rise in temperature, we have installed this ventilation system, which is a noiseless fan, so it will not cause any noise pollution. This fan switch on when there is a rise in temperature. It works in accordance with temperature sensor. So right now the fan is on. So this will cool down the granary, which will save the grains from getting destroyed. So for making this all process centralized and be able to measure all the sensor data, be it flame sensor, humidity or motion, from remote locations, we make use of this board IoT device, which is a Wi-Fi enabled. We can put all the sensors on this, which can be made on the app.
So we also plan to have a Raspberry Pi module along with the camera. The camera will enable us to remotely monitor the granary conditions and will enable the farmer to see his grains remotely from an application which we are also in the process of designing.
Now, if our project gets selected, we would love to collaborate with these groups which build silos. These companies provide grain storage silos in India, and these are spread all over the country in northern as well as the west, and in some in south also. Also, these are some agri-tech innovators which are already established, and are some engineering enterprises and startups which are working in this field, and we will also love to collaborate with these companies. So thank you for providing us the wonderful opportunity to present our ideas.